Hello, I'm now will be demonstrating how to do rank conditions for identifications for simultaneous equations. Suppose we have two structural equations in the simultaneous system, be the y1 and y2 as endogenous variable. So y1t is equivalent to beta naught plus beta 1 y2t plus beta 2 x2t and plus u1t. y2t is equivalent to alpha naught plus alpha 1 y1t and u2t. First of all, to do rank conditions, we need to arrange these two equations in such a way that it is expressed in terms of ut, the error term. So this is the way it is. So now we need to see first. We need to identify first equations, second equations in the row. So we have already this. Second, we need to identify as well the variables. This is variables, so we write down here variables of y1t. This is also the variables. We need to write down here y2t. This is not the variables, sorry. Beta naught is not a variable as it is a coefficient. So the variable is actually 1. So just put 1. Here same goes to here. So we have already variables of 1. y2t is a variable which we have already here. Then x2t as a variable. Here also we have y1t which we have included also. So from the first equations we have a variable of y1t here with the coefficient of 1. So the coefficients we write down 1. Here we have variables of here y2t, in which in the first equations we do not have y2t. We do have y2t with the coefficients of minus beta 1. So next we have a variables of 1 here with the coefficients of beta naught minus beta naught, which is our constant. So we have also x2t variable which is coefficients of beta 2. Okay, we continue to u2t. u1t we do have it here with the coefficients of alpha 1. u2t y2t y1t we have alpha 1, sorry, not u1t. y2t we do have as well as our variable, so it's 1. And then variable of 1 we do have as minus alpha naught, but notice that we do not have x2t, so it's 0. So how do we find a rank now? So let's start from the first equations. Firstly, for y1t we need to find a rank of matrix that we call as A. Rank A. But before that we need to determine the matrix A itself. How to determine matrix A? Here we do not have any matrix A because in A there is no 0. So if there is no 0, then matrix A does not exist. If matrix A does not exist, then rank A is equivalent to 0. So how many structural equations that we have? Which we have 2, and then we need to minus 1. So here now rank A is less than g minus 1, which is 0 less than 1. So it means equations, the first equations not identified. We continue to the second equations, which is correspond to u2t. here we do have 0. Then how do we define matrix A? Is like this. We close the 0, then we see we don't have lower value here, so we need to refer to the upper value. So then our matrix is, the first column will be beta 2. Sorry. That's all. We do not have any other 0. So the first column will be our first row as well, and the only column in the row. So rank of this matrix is just 1. So G minus 1 as the same is 1. So rank A, matrix A here is equivalent to G minus 1, which these equations, second equations, is identified. So how if this becomes 0? How if? Then the matrix will be, first you need to close this, beta 1, then there is no other 0, there's no 0 here. If there is there is no other value here, downside. If there is other value, let's say gamma 2, then the matrix will be gamma 2 and beta 1, first column. But here there is no, so it's only beta 1. So here also we close, then we have beta 2 minus beta 2. So the matrix will be like this. The rank of this matrix is still 1, because we have 2 columns and 1 row. Rank of a matrix is the minimum of number of row and column, unless the determinant is 0. So yeah, I hope that helps. Thank you.